So that means I've got to get a review out to you to get ready for that last exam next Wednesday. And I have the review, I've been working on it. So I have that review ready for you this Wednesday. So when you turn in your quiz, you'll pick up the review. So that's your last exam is next Wednesday. Monday's a holiday, so don't come to campus. We have no class on Monday. We get Monday off, okay? Now, I was looking at how much more we have to cover in the little time we have to cover it. So I'm gonna start chapter 6 tonight. Chapter 7 is one of the shortest chapters ever. So chapter 7 will be a breeze when I finally get to it. And then we have to do a little touching upon chapter 11. And we'll do just a little bit there in chapter 11 before you guys exit the course. And just a topic or two in chapter 9. So all that's going to work out for us. And you should be ready to move on to Math 7. Okay? Guys, the exams, I will commend you. I thought when I first constructed the test, and I had some pretty challenging problems on there. I thought though the class that might be the hardest of the exam so far. And for this class, it turned out to be nice. I think I had what, 11 A's? Unheard of on this test. 11 A's, and I think 4 of those were scores of 80 out of 80. What did help was that extra credit on the end of the exam. That's just kind of for the exam. That extra credit did cover some mistakes some students made. So guys, I'm proud of you. I thought maybe the scores would really drop on this one because of the material, but you guys did it, okay? Please stick with it. I don't want my class to go down to 4 or 5 students. I don't want that to happen. You guys have worked hard, so let's finish this course up. Now, the only thing is, if you check Canvas, and Canvas is going to give you a grade to you. Don't contact Ramsey after this class is over, unless you want to give me a nice compliment of some sort. Don't contact Ramsey and say, how did I get a C? I may say a few things I shouldn't be saying in my response. Okay, so don't do that, because Canvas is going to show you. Right now, you know your grade. Canvas has it right there staring at you. Now, are some of those grades way up there, like 88%? Yes. But what does it take to get an A? Canvas says 90. So if it's not at 90, Canvas is going to give you a B. And Ramsey is going to give you a B. So some of my students are very close to another grade. So this quiz coming up and the exam coming up next Wednesday and your final exam counts. Okay, right there on the edge. Many of us are right on the edge. Yeah.
The exam, you can cover all of chapter 5 and some of 6, or?
Oh, for the exam next Wednesday?
Yeah.
5, okay. I'll see you guys on Wednesday of this week, of course. I think I have the topics and sections listed on your review. I do. So you'll see the sections you are responsible for when you pick up your review. Okay? Guys, any questions? I'm proud of you. I've been bragging on you. And my colleagues who are doing the Math 7 in the fall are asking for you guys. Say, Ramsey, please give me some names. I've asked them to come on in. We'll add them. One instructor just meets them at the door and says, are you from Ramsey's class? And they're on the wait list. Come on in. I'll give you an ad code. So please, they're waiting for you. So I'm anxious to see what you do. That's going to be a different personality. We all have different personalities as professors, different strategies. So it'll be different. It'll be a little different. You get accustomed to another instructor, but that's the way it happens. But you'll be in a new course. Okay. Now, here's what I got to do. My 4 o'clock session met with me. We have to take a look at the 6 graphs. There are 6 graphs we're responsible for. There are 6 trig functions that we're responsible for. I have those. I have many handouts. I have those to pass out here shortly. I'm going to do something else first. So they're here. So you'll see the shape of all 6. I have this. I noticed this handout had these in degrees. I would prefer radians, but at least you see the shape. So you'll see the shape of sine, what the shape of cosine looks like, and then those that I have not touched yet in class, tan and cotan, secant and cosecant. So you'll see all those. Now, we're responsible for the domain, the range, and some other things about these. And then what's going to take a little time today for me is to take one or two of these and start transformations on it. Take one of these basic parent graphs and start shifting it around or reflecting it. So guys, you'll get this here shortly. On the other side of the handout, this is like a little recap. That's the things we've already done. So you can take a look at this as a little resource or reference, okay? Now, though, what I need before I get this passed out to you, and I'm gonna make all this connect for us the best we can. One of my students, Kim, in the 4 o'clock session, she's doing her homework. She says, Professor, I saw something unusual in one of those sections, and guys, I better mention now, the sections you're responsible for on the quiz Wednesday are these sections. Section 5.2, 5.3. Only 2 sections for this quiz coming up. I would jump into those 2 sections. I would try what I could for homework, get a little practice in those 2 sections, okay? And I'm gonna do a few things myself in class tonight. Now, I think, if I'm not mistaken, I held you guys responsible for that one on the last exam. Didn't I? So that means I gotta go back and see something else in section 5.2. But those are the only 2 sections you're responsible for on this quiz coming up on Wednesday. Now, what am I gonna do? Kim helped me out here. I was planning to do this, and all of a sudden she asked something about one of the problems. First though, in part 1, guys, if you're asked to do this, find the exact value of these. And here goes. My first one looks like this. No calculator. You see something like this staring at you on Wednesday. We want an answer. Almost like an arithmetic problem. Now that, you can see something like that. Please tell me, does my first example contain those that you can find on the unit circle? Do we recognize those? I see a pi over 3, or was it pi over 6? I see a pi over 4 involved here, and I see a pi over 3. Those values can be discovered in the unit circle, which we should know. I need values here, guys. First, this one's easy. The sine of pi over 6, for goodness sakes, by now we all know is 1/2. Is that true?
Yes.
That's the y coordinate. This one may take a little effort. I don't think 11 pi over 4 is one of those on the unit circle, is it? Okay, so I might want to do what we were doing in class last week, divide 4 into 11 pi, and make this 2 pi, 8, remainder of 3 pi, and guys, express it like this. So there's 11 pi over 4, if I made no mistake, expressed. Now, why did I do that? Because I do not know that right now, so I'm going to sketch it right quickly. Sketch it over here on the side. So I'm sketching this, guys. 2 pi means 1 complete revolution. And then move from there an additional 3 pi over 4. If you like degrees, that's 135 degrees. So from there, you got to pick up and move an additional 135. Definitely that's beyond 90, less than 180. So am I in quadrant 2? And I know my signs here are what? Positive or negative positive if I'm in quadrant 2. Is that true? Yeah, I'm looking for a cosine. Well, right now I know cosine must be negative. Now, that's what I'm going to ask you to do for a point on that quiz Wednesday. I want you to first, before you give me an answer, express cosine of 11 pi over 4 in a different manner. Make it look more sophisticated. First, I know it's going to be negative. And it should be the same as negative cosine of, thank you, it takes me back to that unit circle. Now you're talking about amazing when you think about what's going on here. Cosine, the part I blocked off, cosine 11 pi over 4 can be expressed as negative cosine pi over 4. And I see pi over 4 embedded right here, so I know that pi over 4 is its reference angle. Does everyone make sense of that now? So I'm going to ask you first do this, then give me an answer for it. And now, guys, the answer in the red up there will be, of course, negative, and cosine of pi over 4, we all know. From the unit circle is radical 2 over 2. Is that true? Now, to finish it up all together for the second term, I noticed there was a 3 out front. So, guys, I got 3 times that. So let's write this as altogether, it's going to be a negative 3 radical 2 over 2. Is that true? Is that the final value for the second term? Now, in the end, and I need to erase this right here. Make sure you have all that copied down. Now, I'm on the third term. Well, the third term is asking me to find secant of 10 pi over 3, then squared. Well, first, we do this to see where I am. Let's do the long division. I guess that's 3 pi. That's 9 pi. Remainder of pi. So this can be expressed as 3 pi plus pi over 3. To locate it, like I did the previous part there, 3 pi is 1 complete revolution. That's 2 pi. An additional half circle, that's pi, that's 3 pi. And then from there, move an additional 60 degrees if you wish, or pi over 3. So that's going to take me down into quadrant 3. And I know my signs down there are those. Is that true? Now, here we go, guys. This says, please, we need first to express secant of 10 pi over 3, just secant. Based on what you see here, and secant's definition, a little reminder, is 1 over x, where the x is negative. So this could be expressed as negative secant of, now what do you think will be its reference angle? Pi over 3. That's the size of that little angle right there in the corner. In fact, I saw it embedded. Gave me a hint. It was there to begin with. So let's finish this up, guys. It's negative. Now, secant of pi over 3, you will not know what that is unless you recall from the unit circle. Does anyone recall what those coordinates were for pi over 3? 1 half.
And
Radical 3 over 2. You got to know all this. I don't want anyone to mess up now, not after those good scores on that last exam. Now looking for secant. Secant's 1 over x. Ah, easy then. My x is 1 half, so it's 1 over 1 half, which comes out to be what? Negative 2? Okay. It says to square that though. So not quite finished. So back here to the last term. See what this is going to look like. It says negative 2. And guys, if I square this, and we got a negative 2, can I call this a 4? Yes or no? And now altogether, that last term is, if there's no mistake, is it negative 8? All you have to do is put all this mess together with a common denominator and write the answer. Guys, if you don't mind, I'm going to write like this, 1 half with a common denominator of 2. Why not rewrite that 8 on the end as 16 over 2? And put it all together. Right now, if you want everything over 2, no problem. That would be 1 minus 3 radical 2 for the numerators, subtract 16. Better yet, 1 subtract 16 can be combined to a negative 15. Still got this, strange looking answer, all over 2. And there's my final answer. You guys follow the logic? Okay. The thing that's a little different here is I'm gonna ask you to express these in terms of the reference angle, like we did here also. Guys, any concerns here? So you're going to know your unit circle. You have to know your relationships, identities on these. Now part B, I brought one in. And like I said, one of my students came in the 4 o'clock session and asked about something from homework. I thought, good, because this looks like something I have in my notes here. Another one, find the exact value of this. And I don't think this is the same one we did in the 4 o'clock session. Now watch carefully. I don't want anyone to lose a point on that quiz Wednesday. They're asking me to take that and add it up, and you may say, Professor, I guess you're a little tired today. Didn't you mean 45 here? No. It would have helped, Professor, if you had put 135 here. Is that true? Or 225 here. You can find all those on the unit circle. Maybe, I don't know, 330, 3 something that you can see on the unit circle. No, I didn't do it. Now, here we go. You got to get an answer. Some way. Guys, the 40 degrees, I'm gonna leave that the way it is for right now. That looks nice. It's this 130. Okay, what tell me, where is 130, I have this in degrees this time. Where is 130 located when I sketch it? Quadrant 2. Looks like this. That's 130 degrees. Now, can you tell me what on earth is this little angle here stuck in the corner? 50. That's its reference. Now it's usually seen as over here. So guys, tell me a good way to re-express this using what you see here. I'm doing a sine, and sine is y. I'm in quadrant 2, so I know the y should be positive. So it should be positive sine of what? 50. Sine 130 is the same as sine 50, which I'll leave as sine 50. Now here, I'm at 220, if I sketch it, 1 revolution down here, not 1 revolution, just a sketch. Do I terminate in quadrant 3? 220. So I know my signs, if I need them, are those. I'm in quadrant 3. Guys, does anyone have an idea of what size angle is that in the corner here along the x-axis? Because that's the reference angle. 40. 180 plus 40 is 220. So now with that said, can someone tell me what the sine, which should be y here, sine of 220 can be expressed as? Beautiful. Negative sine 40. Yeah, 40. Now the last one, 310 degrees. 310 degrees. Looks like I'm going to end up in quadrant 4. 310. And can anyone tell me the size of this little angle in the corner along the x-axis, which is its reference?
50.
That's 50. And I'm going to mark this as I'm in quadrant 4. The coordinates are those. I'm doing sine. Oh, it's another negative. So how could I express sine 310 based on what you see here? Negative sine 50. Now, have you seen 50 degrees on that unit circle? No. Have you seen 310? No. 130? No. 40? No. But a little bit of thinking here, guys. I think, watch carefully, will these two terms, that first term I did nothing with it, but will it cancel with that? And will these two cancel? Are you kidding? The answer is 0. That's true. Got another relationships there. Okay, so make sure you do not lose points. Some of my students get carried away. They don't show enough work, or I say show all work, show all work, show all work. You gotta show the work. Especially now on the quiz Wednesday, you gotta show how to express this, like this. Gotta see that relationship, critical, and then get your answer. Guys, any concerns on that before I leave it? Okay. Now, part 2. Another part of the quiz, Wednesday. I'm gonna give you some information. This one, I'll give you this. Tan is -1/3. And sine is positive. With that information, find the value of the remaining trig functions. Let me say, cut it short, remaining functions. Now this, for my best students, if you're not careful, I can mess up on it. So guys, find the value of the remaining trig functions. Say, what's remaining, Professor? Well, sines, remaining, no answer yet. Cosine's missing. Tangent's given to me. Let's say secant's missing. Cosecant's missing. And number 5, I guess cotangent's missing. Now, that's a little space in between for a reason. My 4 o'clock session knows what's going to happen. When you finally decide that you know one of the values of one of those 5 remaining trig functions based on what was given, you have to validate it with one of the identities that we've had in class. So guys, please tell me, before I jump into it, let's list, since I haven't seen you for a while, the trig identities, properties that we discussed last week. Now, it may not be in the same order, but I think we said tangent could be expressed as sine over cosine as what they call an identity. That's in your notes. Cotangent, you pick up this one next, could be expressed as 1 over tan. They are reciprocals. Or, if you wish, cosine over sine. We did those last week. Okay, got tan, cotan, secant. Secant can be expressed as 1 over cosine. Those two are reciprocals. Number 4, cosecant has an identity, 1 over sine. I think I have a handout tonight coming up that has all of these listed. Now, I've listed 4. Now, can someone help me to list more of the so-called trig identities?
Sine squared plus cosine squared plus.
Absolutely. Now, can anyone tell me another one that may help? Got no own.
1 plus
1 plus,
cotangent squared,
and that's equal to,
cosecant squared.
beautiful. And guys, I think we'll list one more. Tell me one more.
Tangent squared theta plus 1.
Yeah, tangent squared, theta plus 1 is equal to secant squared. Now, Billy, remind the class, you told me in the 4 o'clock session, if for some reason you're having a bad day Wednesday, and you can't remember these 2, which may help you, but you've just forgotten what they look like, you've forgotten them. Billy, tell the class what you could do to derive them yourself.
You could take identity number 5 and divide it by
divide everything by cosine, both sides, or divide everything by sine, and you'll get these two. Okay, so guys, I think those are the basic ones we did in class. Now, can someone tell me, based on the blue, identities, trig identities? I'm looking for 5 of these remaining trig functions. They gave me this one. Since they gave me this one, it might be easiest to find one that's related to it. And get that one out of the way. That's the way I do it. So guys, for tan to be a negative 1/3, is there one of these that relates fairly easily to tan? Where was it? Cotangent? They are reciprocals. So I could quickly say cotangent, and I have cotangent listed here, would be easily written as the reciprocal of negative 1/3. Negative 3. But, then you have to show me, tell me, the identity that you were using. What were we using number 2 there? Or were we? No, we were using, where is it? I can't even find it. Oh yeah, we were, number 2. Cotangent can be expressed as 1 over tan. There's your validation. I gotta see it. You gotta see which of those identities are you using. Now, it's up in the air. We got 1, 2, 3, 4. 4 missing. Anyone tell me how to find one of those 4 and tell me which identity you would like to use? Shane, go for it.
I'll go for sine, I guess.
Okay, go for sine. And which identity would you like to use?
Tangent equals sine over cosine.
Okay, tangents equals sine over cosine. Okay. Hang on a second. Shane, I agree 100%. This is true. Oh, yes, I'm glad she brought this in. That is definitely true. And you're saying, Professor, tan was given to me as a negative 1/3. So what would you like to do with that?
Well, I would like to find r, and then.
Whoa, we haven't discussed R.
I can't do that, okay.
Not yet. That's coming up in another chapter.
Well, yeah.
So that tan is equal to sine over cosine might be out of the way, or maybe.
Well, it implies that sine theta is the top one, so that would be.
Whoa. So you're saying this.
Yeah.
Professor, that up there was -1, this is 3, right?
Yeah.
Come on, Professor, use a little common sense. Tan is sine over cosine, right? And the top is like -1, so sine must be -1, and therefore cosine is 3. That's the reason I brought this in. Shane, I set you up. What's wrong with that? I'd love to say right now, as a student, I probably would do the same thing Shane did. I'd quickly say, Professor, go ahead and put -1 here. You got another answer out of the way. And cosine is 3. And then get your quiz back and you missed both. You probably missed others. Bella, what's going on with it?
Sine theta is greater than 0.
Tell again.
Sine theta is greater than 0.
Says sine theta must be positive. Is that true? Which I have not looked at yet. Is that true, guys?
Sure.
Okay. Now, be careful here. Tell me another rationale why, Shane, as a student, I would do the same thing you did. What, with that -1 and 3 being recognized, what's telling me as I stare at, no, it looks so reasonable, but it cannot be. Alex?
If you do -1 squared plus 3 squared is equal 1.
He said, wait, Professor, sine squared plus cosine squared is supposed to be 1. So if you square this, you get what, 1? You square 3, you go, what, 9? You add them up, you get what? 10. That's another reason you can't do what we're doing right now. Now I see one more. Or probably more, but I see one more I'm thinking of. Ignacio,
Cosine can be bigger than 1.
look at this. Cosine is equal to 3. Have you seen on the unit circle cosine being equal to 3? Anyone, please tell me, on that unit circle, how high up does it go? 1. You can't have cosine be a 3. So for all those different reasons you guys gave me, I can't do this. Now have I seen students do this? Then walk out of here and get a 0 on the quiz? Huh. Okay. So I must come up with some other reasoning here. Now, Shane, let me do this. Let me go ahead. Now, see, you called my attention to it. Before we get back and try to find something here, let's see which quadrant are they talking about first. They're saying tangent is negative. It's negative 1/3. Guys, where of the 4 quadrants when you put y over x? That's what tangent is. Out of the 4 quadrants, when you put y over x, where are you guaranteed you're going to get a negative result? 2 and what? 4. At the same time, we're saying, don't stop there. Now, which quadrants would give you a sign, which by definition is y?
1 and 2.
Yeah, where is y? Positive. 1 and 2. They match up in, where am I? To my angle they're discussing is in quadrant 2. That tells me, if you wish to do it right now, that I'm in quadrant 2. If I'm in quadrant 2, we all know the coordinates from middle school are these. Is that true? So if you'd like to now find the signs of the remaining trig functions, get the signs out of the way, you can do that now. We'll worry about the values here shortly. Let's get the signs out of the way, guys. A sign in quadrant 2. Positive. It's y. Cosine, if I'm in quadrant 2, and that's where I am, in quadrant 2, cosine is x by definition, it is negative. Secant is 1 over x, where x is negative. Is that also negative? Cosecant is 1 over y. You've got to know all these definitions, where y is positive. That's positive. And of course, we've already got the cotangent. Is that true? At least the signs are there. Now this thing is loaded because you've got lots of points here going on. Now let's try to find some values. Shane, I can't do what you suggested. We have many reasons why we could not. So guys, does anyone have an idea, based on this, another one of these properties that you might want to use to find something else? I don't care which one you find, as long as you can validate it with one of those properties. Say it again. Cosecant. Okay, let's try to find cosecant. I know it's positive. And what would you like to use to find cosecant? You gotta use one of these. Which one now?
1 plus cotangent squared.
1 plus cotangent squared. Hold on. Billy, I think that's you. You want to use this. You have to validate. You gotta tell me which one that you want to use this. And she says, Professor, you've already found cotangent number 5 is negative 3. Put that in. It's got to be squared. It's equal to this. These take a little time to do, guys. Finish that up. I'm squeezing in, guys. This is 1 plus 9 equals cosecant squared. Now I'm running out of space there. Does everyone see that 1 plus 9 is 10? Is that true? And then I need to do what to find cosecant? Do a square root. I got cosecant squared. So is it at this point square root 10? And it's already a positive. We got that out of the way. Billy, thank you so much. That's another value out of the way and validated. Now, does anyone see something in the blue to fill in anything else?
Sine.
Or you want sine? How are you going to find sine?
1 over cosecant.
Oh, beautiful. So you're going to be using this identity here. So cosecant is equal to, oops, yeah. Is equal to 1 over sine. That's what Alex has in mind. And guys, this really says they are reciprocals. Well, we just found cosecant with Billy's help, I think it was, to be this. So I need the reciprocal of this. 1 over radical 10. As positive. Rationalize, clean it up, simplify. Please tell me, is it that? True? Okay. we have two more values we gotta find. It's a negative and a negative. I gotta find cosine, secant. Does anyone have one of those over there I gotta use to find it? Find one of those. Which one you wanna find? Secant? And tell me which identity are you gonna use?
Tan squared plus 1 equals secant.
Beautiful. This is my validation. Okay, tan squared plus 1, guys, I'm looking through. Oh, they gave tan to me. That's a negative 1/3. Plus 1 equals secant squared. Guys, by doing my math here, please help me out. Is this 1/9 plus 1? Or 1/9 plus 9/9? Was it 10 over 9? 10 over 9. Just doing a little arithmetic there, equals secant squared. Don't let me mess up. Take a square root, and the best I can say here is radical 10 over what? 3. That's the value. The sign for this we had earlier, so this is of course a negative, so this is square root 10 over 3. Wow. We have one value remaining. Does anyone have an idea how to find cosine?
1 over secant.
Okay, so secant is equal to 1 over cosine, I think. So here we go. In other words, these two are reciprocals. And I think we found secant right here. Now it's gonna look strange. I gotta flip this over, form the reciprocal. And we end up with, of course, I see a negative sign there already. 3 over radical 10. Rationalize, let me carry my negative sign with me. 3 radical 10 over 10, see if you guys will agree. Yes or no? Now, do we have all the values done? Is that true? All the values have been done. Now, here's the issue. This thing is so loaded for a quiz problem. Because you're going to get some type of a point, half a point, or maybe some point. For the blue, and that's, you got to show me what you're using here. You get something for that. And then, of course, you get something for your final answer. Okay, so this thing is loaded with ways to gain some points there. Now take a close look. Would one of these easily be missed? I miss some myself sometimes. I'll work too fast, I may make a mistake here, and if you make a mistake here, more than likely you're going to use this to find another one of these. You're going to make another mistake. So be very, very careful here on this. Guys, any concerns? Let me step back and look. That's your quiz. There's the types of problems you see on that quiz on Wednesday. Any concerns before I erase this? I think it's a nice little recap. Okay. Now what I need to do though, and I've got to do a good job with this tonight, these graphs.
Question.
Who has a question?
On
Go
the
ahead.
quiz, we would only get those weird angles if something like that's gonna happen, right? Like we're not actually gonna try to find the sign and the
Whoa,
cosine.
whoa, 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 you mean here?
Yeah.
Oh yeah, exactly. No, no, no. I'm gonna give you some strange ones. Like I did here, you've never seen 40 degrees before, but somehow it's gonna relate to the others, and something starts canceling out. That's all I can do with it. Yeah. Okay, guys, here's what I've been looking forward to. That's part 2 there done. Part 3, my sketches, my graphs, to leave chapter 5. And Mr. Park, I think you sent out a handout last week, I think it was, that had the parent graphs on it. I think, right?
I wasn't here Wednesday.
No. I think I looked at what you sent out to them. And I think you did send out maybe 4 handouts. You guys recall that? Yeah, I think he sent out a copy. I may give you guys a copy in class. But he sent out also what the 6 graphs look like. I think I had 4 handouts. Guys, first, this one. Most basic one. Let me check my notes and see if I did what I should have done with this. Oh, yes, Ramsey. Here we go. Let's get this one out of the way real quickly, and then I gotta look at some of the others. Guys, the sine graph, the sine wave, I think most students recognize it, but, a recap here. Start with 0, pi over 2, pi, 3 pi over 2, and out to 2 pi. And then on the y-axis, we went up to a 1 and down to a -1. I'm going to draw one cycle. And we decided, I think from last week, please tell me, did we do sine last week?
Yeah.
I think we did. When we graph this, guys, we started out with 0. At pi over 2, went up to 1. Pi back at 0. 3 pi over 2, -1. 2 pi, 0. And we have a graph that looks something like this. For one cycle. Now, could I draw more cycles? I think I mentioned that last week. Of course you could. You could pick up here 2 pi and draw another. It just repeats. I could draw on the left. It drops down, comes back up. So it's infinity on both ends. You could just continue with those cycles. I have one cycle here. Guys, we decided the domain on this function altogether, just write like this, is all real numbers, goes forever. Range, though, on this function, the up and down, from a -1 up to 1. Period, the point at which it might start repeating. If I'd like to draw another cycle, looks like maybe 2 pi, it would pick up and we could draw another cycle, which will play a big part here shortly. And there's something called amplitude. Let me just abbreviate. Amplitude was the highest point from the axis that my graph goes up to. So in my case, the graph goes up to what, a 1? And those are some characteristics that we did. We did this one. Now remind me, class, did I have a chance to do cosine?
Yes.
Or was it cosecant?
No.
I think I did cosecant. Did we, the one we did last week, did we have asymptotes?
Yeah.
That's cosecant. I have not done cosine. So I'm gonna do cosine next. See what that graph may look like. Close down chapter 5 here. This is called cosine x. Guys, on the grid here, I'm gonna ask for your help. I'm gonna draw one cycle. We'll accept that as the parent graph. And you'll say, Professor, what are you going to do? I'm going to use the same x-axis, same numbers, these numbers, again. Have this. And of course, we'll go up to a 1, down to a -1, I'll mark mine like that. Anyone remind me, where'd these numbers come from? Yeah, but where'd they come from? The unit circle. Okay, they came from the unit circle on this one. Now I'm doing cosine, and cosine's definition, don't confuse that x there. If you want to put theta here on this one, go for it. Because the definition for cosine is x. I don't want you to confuse those. It's x by definition. Now, can anyone remind me on the unit circle, what was the x coordinate? Was it 1?
Yeah.
Okay, so that means my graph's going to start at 1 here. Pi over 2 up at 90 degrees, pi over 2. Can anyone tell me what the x coordinate, which is cosine, was up there? 0. At pi, please tell me, was it -1? 3 pi over 2 on the unit circle, the x coordinate, cosine 0. And finally 2 pi, you're back up at 1. That graph looks something like this. For one cycle. Now, could I pick up and draw more cycles? I could. Could I draw a cycle on the left? I could. We'll accept our parent graph for this class as that. We'll just accept that one cycle. Let's accept that as my parent graph. Now, domain, range, and all that business, guys, the domain of the function, though, will be recognized as all real numbers. Done. Range on this function is -1 up to 1. That's no problem. The period, now what do you think I'll accept as the period, the point at which I could pick up and draw another cycle? Is it 2 pi? And the amplitude, I'll put it down here just to abbreviate that, is again 1. Those are some characteristics of my cosine graph. So guys, sine graph, cosine graph, I did cosecant last week. Now we'll just do 2 more. And let you guys figure out the other one. I'm not going to do cotangent for you. I'm going to do secant, and what else am I leaving out? I've got sine, cosine, tangent. Okay, I have not done tangent. I have not done secant. We'll do those 2. Now, before I leave this one, here's the issue for you on your exam next week. Bear with me. Before I show you a new graph here, I will do something with this cosine. I would like to sketch, and don't get scared. Sketch this. Y is equal to this. Looks like that. Step back and look at it. Oh. I do see a cosine mentioned. So it should resemble its parent, this graph. Now, I'm going to do this. Can anyone help me out? I need all these different colors going on here. If we were to do it through transformations, what would that indicate to do? Reflected through the x-axis. Can someone be clever? I've got a clever class. Oh, I'm not. The 2. I'm gonna flip it out. This might indicate to do what? Vertical stretch. By 2. Now, in this clever class, who has an idea of what to do with pi over 4 subtract 2x? Because I'll be doing more transformations. Alex tells class what to do.
You make it -2x plus pi over 4.
Do it again.
You make it -2x plus pi over 4.
First he says, Professor, you better rewrite it and have that x to come first. And he wants me to rewrite it as -2x plus pi over 4. Love it. What else should I do?
Factor out -1.
Oh, in fact, better than that. I could factor out -1. Alexander, was that you? Who said factor out? Shane. I could. Even a little bit better. Factor out -2. You have the x completely by itself. So if I factor out -2, you've got to be careful. Definitely have x, it's going to be a minus. Now what on earth are you going to have on the end? If you're factoring out a -2 from pi over 4.
Pi over 8.
Thank you. And for a quick check, you use the restricted property here, that takes you right back to this. You use the distributive property for a check. And then finally, we've got +3. Now, Ignacio, use purple, green, and stripe blue if we were to do it through transformations. Can you tell me what that might mean to do?
It's a reflection about the y-axis.
Are you kidding? It's a reflection, again, through the y-axis. Try black next. This might tell me
Horizontal shrink.
a horizontal shrink by a factor of 1/2. Shrink here by a factor of 1/2. As if that's not enough, and I'm running out of different colors here, I see a +3 staring at me, and that might indicate to me, if I can find something here. Here it is. This will work. What does this mean? A vertical shift up 3. Alexandra, I wish as an instructor, and I wish as a class we had time. You got to put the parent graph. So first you start with this graph. And then you would start your transformations. If I count these, I have 1, 2, 3, 4, 5. Do I have 5 transformations to do on that graph? We'll be here all day. But that's what it means to do. Go through those 5 transformations. Now, if I give you one of these to do, I have some students who are really quick. They can do it. And they're now very good at those different colors. And I guarantee you some students could, in this class, could quickly go through all these different transformations and say, Professor, my final graph is, and they have it marked for me. It's so time consuming. We could do it. Now the calc instructors, that's what I'm worried about, they're going to actually do some calculus on this. They're not, don't sit there and say, well, Ramsey showed us you gotta do 5 transformations. No, they want the graph real quickly done because they want you to go to a calc technique. They want the graph almost immediately. Now, I need some input here. Shane, what do you got?
Well, I have a question.
Go ahead.
Would not be 6 transformations with a horizontal shift of the.
Did we leave that out?
Yeah, we've been,
Where is it? Oh my goodness, boy, Shane, thank you. I'm on top here and I didn't see it. You're talking about this.
yeah,
Another transformation. What, a horizontal shift to the right, pi/8. Not shrink, but shift to the right. Ignacio, that could be your final exam. That may take some of my students, I know how my students are on a quiz or exam, they'll work, if I gave them 3 hours, they'd be in here 3 hours. You probably could work on that for 3 hours and finally get it, doing all those transformations. We don't have that time to do it. I like to just know, where is that graph? Give me a sketch of a graph, please. I saw a hand go up. Alex, was that the same thing about the horizontal shift? I left it out?
Yeah.
You brought my attention. Shane, thank you. Guys, got all that done? I'm not gonna do it through transformations. You said, Ramsey, we still need a graph though. This is what we're gonna do. I will do some of these transformations, not all of these. Guys, let me think of a good way to introduce this. Oh boy, what am I going to do? My parent graph is bounded by what? By 1 cycle. If we start at 0 and end at 2 pi. I would love, since the parent did this, to bound this one the same way, between 0 and 2 pi. So that means, take this, what they call the argument, and bound it between 0 and 2 pi. We'll do that first. That part right here is going to be bounded based on the parent between 0 and 2 pi. We said, Professor, whether we rewrote this, did we not, as this? Did we rewrite it as this? So guys, we have a negative 2 times x subtract pi over 8 is going to be bounded between what two numbers? What the parent was? 0 and 2 pi. Is that true? I'm just basing it on the parent. So it's got to be bounded between these two as the parent was. I did bound it. This part here has been bounded, done. I'm going to solve this inequality here shortly. Do we all have this set up correctly? I think so. Now I've got to solve it. Guys, if I solve it now, it looks like somewhere I have to multiply or divide by negative. Will those inequality symbols reverse? I don't want that to happen. I'd like for it to stay less than, like here. Jeez, for that one cycle. Okay, here goes. I'll come back to this. Those separate lessons. We have to identify even and odd properties for the trig functions. Does anyone remember a definition to see whether a function was even to begin with? Let's get even out of the way first. How does one identify, for an example, that f of x equals x squared is an even function?
F of negative x,
Is equal to,
f of x.
if that happens, your function is an even function. And f of x equals x squared is a good example to think of. On the other hand, your function could be an odd function, like x cubed. What happens there?
F of negative x
F of negative x.
is equal to negative f.
There you go, we had this. Did we not? So I need now, at this point, to identify my cosine graph. Is it even or odd? My trig graphs, my trig functions also can be identified as even or odd. Let me remind you guys, back in middle school, that teacher back there would say an even function, a good example to think of is this. That's even. A good function down here would be x cubed. Is that true? Now, before I get into the trig functions, whether or not it's even or odd, can anyone tell me if you were to graph x squared, which is a parabola, is there some symmetry going on? About the what?
Origin.
The y-axis. Is it symmetric about the y-axis? Is one side of that curve on the parabola on one side of the y-axis, the other side has the other side? This one?
Origin.
Through the origin. So this one, if it's even, should be symmetric through the y-axis. If it's odd, should be symmetric through the origin. Now, Alexandra, Ramsey's given the definitions. Remind you, we've already had these definitions before. Now, I must, for the sake of what I'm going to do here, I must identify this function, cosine, the way it looks, as being even or odd. In other words, I got to show this. Marker here. I got to show this. Cosine of a negative x, if I can show it's equivalent to just cosine x, I can quickly say cosine is even. That would fit Shane's definition here. So if I can show those two sides are equivalent, cosine is an even function, and I can do something special about it. Alex, is it even?
Yeah.
Tell us why.
If you draw like another set on the other side, it's,
Ah, beautiful. You mean if I did this, I can draw another cycle here?
yeah.
Look at this. He's talking about creativity. He says, Professor, if you want to draw another, by the way, guys, with that one more cycle, can you see there is a reflection through the y-axis? So that's one reason, absolutely. So it's an even function. Okay, let's identify as even. It's even. If it's even, here we go. Guys, let me do this, let me do this. Then Shane's definition says f of a negative x, Professor, it should be the same as f of x. Guess what that tells me I'm allowed to do here on this? back here, where was it? You see that negative sign hanging on here? Which I think was inside here, wasn't it?
Yeah.
Where was it? Over here. See this right here? Can anyone tell me what am I allowed to do, which may help me, with that negative sign, since cosine is identified as an even function? I could drop it. Even says f of a negative x is equivalent to what was it Shane told me? It's just f of x, the negative sign's gone. That's one benefit of an even function. So this negative sign that worries me right here, I can drop it. Just because cosine is an even function.
But you had -2 outside.
Oh no, that's something else. We're talking about inside.
Okay,
We're talking about inside here.
okay.
Not outside, Shane, not out here. I'm not doing that business. Inside. And was this inside on my problem? I know I rewrote it, but this was the inside, was it? I love that, because cosine's even, you get to drop this, in other words, this is dropped. You don't have to worry about it. Oh, I see, it looks like, oh, I did not know that, Professor. On an even trig function, if it's negative there, you get to drop it. Now, this will be more easily solved now. Alexander, tell us class what you might try to do to solve for x here. At least that negative sign's gone.
I distribute.
You could. I see something a little easier. You could though. Anyone see something maybe a little bit easier? Even though you could.
Divide by 2.
Divide by what?
2.
Divide by 2. Everything by 2. Thank goodness it's a positive 2. Symbols will not reverse on me. This is still 0. 2's canceled. You got this. And the other side is pi. Now to finally get that x all by itself, because we've got to solve for x, next step would be add pi over 8. Everything. And guys, if I do that, I'm careful. This, of course, is pi over 8. Less than or equal to, these drop out, x. Less than or equal to, if you put these two together, please tell me, is that 9 pi over 8? Yes or no? Is that true? Now, when I start graphing, let me go back to my parent graph. We have an initial point to start with. Then we went to pi over 2, went to pi, 3 pi over 2, 2 pi. On my parent graph, I have 5, let's call them critical points, to work with. Guess what this graph's going to have as its initial point? It's going to start at pi over 8. So pi over 8 is going to be like 0 was here. And guess what the 9 pi over 8 acts as? The end. So the pi over 8 is going to be the initial, 9 pi over 8 is going to be the end. Now, do I have some points missing? Yes, I've got some points missing because I got some points in between, like the parent had. I got to find out what those are, but let me set the grid up. At least I know where it's going to start. It's going to start at pi over 8 for the one cycle of this graph. And it's going to end at 9 pi over 8. And then we'll have to come up with some way to find the intervening points. And then we'll try to graph this. Beautiful. Just enough time to get this done. So guys, we go to the grid and get this one graph done. Okay. It's going to start at 5 or 8. It's going to end at 9 pi over 8. Stretch this out a bit. That's the initial and the end. So we're going to work so far. Now, like the parent had 3 more intervening points in between. I got to find those 3. You want to have an idea?
Add pi over 8 to each of them.
I'm gonna have to say add pi over 8. Where'd you get that pi over 8?
From within, it's the horizontal shift to the right,
Oh, it could happen like that. It could.
but it's also.
I got you, absolutely, I see what you're saying. Ignacio? Say, that's what you're saying.
Subtract pi over 8 from 9 pi over 8.
Now, if I take the ending, subtract the beginning, even on the parent graph, if I took its ending on the parent, subtract the beginning, which was 0, what does that give me?
How long it is?
Does that give me the
The period.
period?
Uh-huh.
So here the period would be, here we go. Ignacio, the ending was what, 9 pi over 8? Subtract the initial, pi over 8. Guys, I think that is
Pi.
pi. Is that true? Just like the parent had. Now, you said, Professor, how's that going to help you to find those intervening points? Okay, I got this. 2 pi. Can anyone give me a clever way to find, let's say pi over 2 on the parent? I know the period's 2 pi. Anyone give me a clever way to find pi over 2? And by the way, before I jump into it, are they evenly spaced here on the parent graph?
Yes.
By an amount of what?
4. I mean,
Uh-uh.
pi over 2.
Are the amount pi over 2? Are you going from here to here, that's pi over 2? From 90 to 180, that's pi over 2. 180 to 270, 90, pi over 2. 270 to 360, 90, pi over 2. So it's evenly spaced. Mine's gotta be evenly spaced. Shane thinks I'm gonna add pi over 8.
Oh, I see.
We'll see. I know the period. The period's pi. How many quadrants are there?
4.
Is on the parent graph, is this considered quadrant 1? From 0 to 90 on the unit circle. From 90 to 180, that's covering quadrant 2. 180 to 270, that's quadrant 3. 270 to 360, that's quadrant 4. I have all 4 quadrants on this grid. I'm gonna have 4 here. So I need to find something to evenly space it. And how many quadrants do I have? I have 4, so why not take this period and divide it by 4? And that'll give my spacing number. Now, did it work on the parent graph? Well, here it was 2 pi divided by 4. Was that the spacing for the parent graph? Pi over 2, 90? So we find the period, ending, subtract the beginning of the cycle, that's the period. Divide that by 4, why 4? I've got 4 quadrants I gotta cover. So that will give me an even spacing. Now guys, here goes. Pi over 4, yes, I need to add pi over 4 here, evenly spaced. I see an 8.
2 pi over 8.
Yeah, let's rewrite this as 2 pi over 8. Much easier for us. Let's go pi over 4. So I need to add 2 pi over 8. So this becomes what? 3 pi over 8. What's that? 5 pi over 8? Don't let me mess up. Was it 7 pi over 8? Help me out, guys. And would it give me a 9 pi over 8 if I finish it up? True? Well, I see some students watching. You gotta watch carefully on this one. Bella.
I'm kind of confused as to why we have to subtract pi over 8 from 9 pi over 8 to find the period.
Okay, the period of the graph is always the ending, subtract the beginning. So like my parent graph ended at 2 pi, it started at 0. And we said the period was 2 pi.
Okay.
So it's always the ending of the cycle, subtract the beginning, will give you that period.
Okay.
So you gotta do that, ending, subtract the beginning.
So period refers to the length.
The length, there you go,
Okay.
exactly, it's the length. And then we'll divide by 4, split it up into 4 equal parts, because there's 4 quadrants, just like my parent. 1, 2, 3, 4. To get my even spacing. Okay, guys, at least I got that much done. I'm looking at the clock now, I know it's almost time for a break, but we'll get this scrapped in. Now, Alexander, after all that business is done, I'm gonna do this. I'm gonna erase this. This we have just done by considering this. That true? That much is out of the way. No transformation. Now, Alexander, I still have to consider though, my graph should be shifted up 3, reflected through the what? X-axis. And if I'm reflecting through the X-axis, guys, please tell me, even on the parent graph, is it going to be upside down? If I'm reflected across the X-axis, so, which I eventually have to do. And I've got to show something about a stretch of 2. If I can get all that done, within the next 5 minutes, we'll be doing wonderful. And that'll be the graph. I would suggest, this is me, I'm gonna get my vertical shift done right now to show, Professor, the graph is up here on an axis at 3. Let me do it like this. So it's shifted up 3, vertical shift. Put it like that. There it is. Negative sign stuck out front, no problem. That means this will be upside down, reflected through the x-axis. Is that true, guys? Now, can anyone tell me the last point is, and we'll start graphing, get this done. What on earth am I going to do if I can find it? What's left? Oh, this, the 2. What's that 2 tell me also is happening? We got the vertical shift up 3, so it's taking place up there. That's going to be upside down, it's going to be reflected through the axis, x-axis. And the 2, what does the 2 tell me to do? Stretch that graph by how much? 2. So I'm not going to stay at 3. Where am I going to go? Where am I going to go? I'm going to eventually go up to 5. Somewhere. Get a stretch of 2. So we're going to mark this as 5. And if I went up 2, I got to drop down 2, so I'm going to go down to a 1. Let's go play a part. Ooh. Now let's graph it. I think we're ready to graph it. I see some looks like, oh, Professor, we're going to try another one of these after the break. Okay, here we go. Guys, I'm going to draw my final graph in green. This green will work out for me. Okay, we've got everything ready? Yes, we do. Now, this is a cosine graph, and cosine is supposed to, unless it's upside down, it's supposed to start up at its max. The parents start at 1. Can anyone tell me where my graph may start? Its starting place is 5 or 8, and it's got to be flipped over. Where might it start? Where should my first point be? Give me an idea. I heard 1. Is it going to start here? Where might it go at 3, 5, or 8?
0.
Might it go up to the axis? Yes or no? It's going to be upside down. What may be happening at 5, 5, or 8? Does it go up to 5? What may be happening at 7, 5, or 8? It's back on 3, the axis. And finally at 9, 5, or 8, back at 1. Connect, should look like the parent except upside down. It's going to look something like this. For one side. Now, you're going to get a break. Just hold on. What you've just done, and I know I've just worked out one problem with this bounding type of situation. What you just done was, remind me again, were there 6 transformations here or 5?
6.
Were there 6 altogether at first? You've just done this in no time without taking the time to do 6 individual transformations, which would take forever. You've got the graph done. After all those transformations are done, you're going to get that. That's your final answer. That's the final graph. Now, are there more cycles to this if I wish? Of course. I could pick up here and you could go back up. Back down. Could it do the same thing here? Of course it could. I could have different cycles. I just have one cycle to look at, and one cycle is enough for me. And I told you about the little a guy from the middle school that came across the street to take that class. I told you guys a story about him. He did something like this on the final exam. He had this cycle way down here and marked perfectly. By the time he got there, he marked those 5 points down there he needed down there. And I was misled. I thought, no, he missed it because I had my graph over here. He had his cycle down here, so I don't care which cycle you draw. Yeah, Bella.
So we don't have to be concerned with the y-axis reflect because it's a cycle?
Because it's odd, or because it's bigger function.
I'm trying to think what you just said there.
Because we dropped the negative.
Oh, yeah, oh, I see what you're saying, the y-axis, you're looking at the y-axis. I think what you're doing here, if I drew another cycle over here,
What did it say? Yeah,
could I look at that reflection across the y-axis?
yeah.
Yeah, that's still true, yeah.
Would we, if we're changing the cycle, then would we have to specify the domain that we're using?
We're gonna do it right now.
It
Close
wouldn't
that. We're gonna do
reflect over the y-axis anymore though, because it would have the shift.
Yeah. Now, let's list the domain, the range, and all that, then we'll take a break here. Guys, if we accept this green graph, here goes. I know it's almost time for a break. My domain of this function, now there was the domain of the entire function, I just have one cycle. Should I call it all real numbers? Because it goes forever. The range though, the up and down, if we have no mistakes, which I hope we don't, is what? 1 up to 5. Period, I think we identified the period earlier with Nasu's help as pi. Amplitude, and here's what I got to be careful with. The amplitude is the highest point, or the, I don't know, what's a good way to describe this. I think I've been described as the highest point from the axis. My axis though is up here.
Farthest distance.
So how many spaces high is it from there?
2.
2. So my amplitude is considered to be at 2. Oh, by the way, also, if you wish, a quick check always, where am I? Was there, I've erased so much here, was there a 2 out front here? To begin with, like a vertical stretch, by a factor of 2, that will also always be your amplitude, that's number stuck out front. Guys, follow the logic? Now, could you do one of these for me next Wednesday? If you're leaving town for vacation, for Monday, you want to take a little day off, you better take your math notes with you. If I go over to Vegas, I'll take my notes with me. Look at my math notes, I've got to construct a test. Jeez. Okay, domain, range, period, amplitude. Now, I'm looking at my time here. You say, Professor, please give us a break here. Here we go, this is the last thing. Same graph, nothing else, we've already got a graph. But I have here, do I have here? Oh, please tell me I do have here something. Yeah, I do. And then we're taking a break. This, I think, will have you to appreciate what we've done. And then we're going to take a break. I'd like to find f of 7, 5, or 8. If my graph is drawn correctly, this is the first one you've seen with this mess, what is the answer?
3.
Yeah, 7, 5, or 8, if my graph is done correctly, it goes up to 3, doesn't it? So f of 7, 5, or 8, based on the graph, is 3. Bella, to close down and to take a break, if I do not get 3, when I go back to the original and replace x by pi over 8, pi over what was it? 7 pi over 8, we've got a mistake. So here goes. Ignacio, help me out here. Was there a -2 stuck out front?
Yes.
Then cosine. Now help me out inside there. What was inside? Original.
5 over 4.
5 over 4.
X,
Subtract what?
2x.
Okay, let's replace that x by this. Close that up, close that up. plus 3. Now, if this does not give me what the graph says it should be 3. The answer should be 3. If it does not give me 3, I'm taking a break with you. I'm gonna take a break. I'm gonna close down and turn the lights off. I'm taking a break. There goes. -2. Cosine. Now, inside there, I know I can cancel 2 into 8 on that part and get a 4. That's true? So I've got pi over 4 subtract 7 pi over 4. What is pi over 4, like in fractions, subtract 7 pi over 4? Is that a -6 pi over 4? Yes or no?
Yes.
That's just arithmetic. That true? Better yet, could I write this, and do not let me make a mistake here, please. Could I reduce that down to a -3 pi over 2? Yes or no?
Yes.
Wow. Whew. And if you wish, you can think about where a -3 pi over 2 is on that unit circle. It's on there somewhere, but it says negative. Does anyone think they know what cosine of the x-coordinate at -3 pi over 2 is?
0.
Please tell me, do we algebraically end up with the same answer as the graph said we should get? That makes me feel better that that graph may be correct. I checked at least one of the points. Should check all 5 of the others. Yeah.
Is the value of the vertical stretch equivalent to the amplitude?
It is, well said. The value of the vertical stretch is the same as the amplitude. Wow, guys, I know it took a little time there, but we got it done. Chapter 5 basically is done.